This is a reading of the beginning of the second book of an Aristotelian dialogue concerning the geocentric and heliocentric cosmologies, Contra Galileo, which I am the author of and which you can find a copy of in the archive and Amazon links below. Again, I wrote this as a response to Galileo's dialogue concerning the two chief world systems, which was the crucial book of the scientific revolution. And I wrote this as a defense of the Aristotelian and Ptolemaic geocentric model of the cosmos, and a refutation of the heliocentric model of the cosmos as portrayed by Copernicus and especially Galileo. Again, this will be a reading of the beginning of book 2, where the actual cosmological arguments begin. As you may have found, and as hopefully was not a distraction, the first book was concerned with more general philosophical discussions about whether there is a difference in substance between the celestial spheres and the bodies carried around by them, and the sublunary elemental bodies, and whether that differentiation is discerned by their difference in motion. The celestial bodies moving in perfect circles, while the elemental bodies like fire and earth moving upward and downward in rectilinear lines, which Galileo had to attack before he could even propose to displace the earth from the center and to set the earth in motion and spinning at the same time. That is why the first book might have seemed like a digression, but Galileo's own first book, in his dialogue concerning the two chief world systems, focused on the same problems that I addressed in book 1 of this work. Whether or not there can be rectilinear motion, whether the sublunary elemental bodies are different from in substance and have different kinds of motion than the celestial bodies, which move circularly in the same way and as natural to them as fire moves upwards and earth downwards, not as an external impressed force that pushes them along, but that the celestial bodies move by their own, by a motion natural to their substance, the same way fire has the natural principle of motion of upward velocity, and earth, once a part is separated and raised up by an external force to earth, falls. Because Galileo had to attack those differentiations, kinds of motion, and then from that, the kinds of substance between celestial and elemental bodies, before he could present an argument about whether or not the earth is set in motion and spinning around another body, around the sun, and whether the sun is motionless at the center, and whether the fixed stars are motionless, like he says, and whether the earth is responsible for the risings and settings that we observe, the sun, the stars, the moon, everything to have. So now we can move on to questions about the position of the different parts of the cosmos. Truly cosmological questions, which Galileo is famous for, and which couldn't have been approached until the sort of ideological or general philosophical concepts were disfigured somewhat. The differentiation between earthen or the elemental bodies and the cyclical heavens and the bodies carried around by the spheres. So to begin with book 2, Simplicius of Cilicia. Now we can advance to more exclusively astronomical content, which is what the masses find to be our fundamental disagreement. I suggest you lead this part of the discussion, Galileo, since it would be out of place for us to try to draw you into the Aristotelian cosmology, rather than let you lay out the general scheme of the theory of Copernicus. The framework of both cosmological systems should be illustrated for our listeners. The argument, I should say, hinges on the mobility or the immobility of the Earth. Copernicus and his followers adducing the movement of the Earth, against the Aristotelians who adduce the contradictory position of the Earth's immobility and stationary nature. Galileo. Then I will begin by introducing the topic at hand, and let the inauguration of our reflections be the consideration that whatever motion comes to be attributed to the Earth must remain necessarily imperceptible to us, and as if non-existent, so long as we look only at terrestrial objects. For as inhabitants of the Earth, we consequentially participate in the same motion. But it is indeed just as necessary that that motion display itself very generally in all other visible bodies and objects which, being separated from the Earth, do not take part in this movement. So the true method of investigating whether any motion can be attributed to the Earth, and if so, what it may be, is to observe whether bodies separated from the Earth exhibit some appearance of motion which belongs equally to them all. For a motion which is perceived only, for example, in the moon, and which does not affect Venus or Jupiter or any of the other stars, cannot in any way be the Earth's or anything but the moon's. Again, for a motion which is perceived only, for example, in the moon, which does not affect Venus or Jupiter or any of the stars, cannot in any way be the Earth's or anything but the moon's. Now there is one motion which is most general and supreme over all, and it is that by which the sun, the moon, and the 5 planets and fixed stars, in a word, the whole cosmos, the Earth alone excepted, appear to be moved as a unit from east to west in the space of 24 hours or a single day. That is the risings and settings of the sun and the moon and everything else. This, insofar as appearances are concerned, may just as logically belong to the Earth alone as to the rest of the cosmos, since the same appearances would prevail as much in the one situation as in the other. Thus it is that Aristotle and Ptolemy, who thoroughly understood this consideration, in their attempt to prove the Earth immovable, they aim their arguments at a solution which accounts for this diurnal motion of risings and settings, which carries the stars and luminaries around with its turning rotary movement. That may serve as an introduction to the topic. Simplicius of Cilicia. That is indeed a fair display of the phenomena that our theories can tend to account for. That is the diurnal motion of risings and settings. Now, before we contend about the motion or stability of the Earth and of the sun, I would like to draw a similarity. We seem to be in a quarrel that might be likened to that which the ancients told in fables as taking place between Atreus and Thyestes. Are you aware of that tale? Galileo, I am not. Which do you mean? Simplicius of Cilicia. I refer to an infamous quarrel between the brothers Atreus and Thyestes over the throne of Mycenae, filled with treachery, a woeful tragedy. Their household was cursed, you see, to be stained with strife and bloodshed. Thyestes, by a deceptive plot, obtained the throne of Mycenae from Atreus, who had agreed that whoever possessed the ram with a golden fleece would be king, knowing that the ram was one amongst his own flock, not knowing, however, that his wife had betrayed him and had given the golden ram to Thyestes, who then claimed the throne of Mycenae. Atreus retook the throne then by a second wager, about which he persuaded Thyestes to agree that if the sun rose in the quarter where it then set, and set in the quarter where it then rose, then the royal scepter of Mycenae and the throne should return to him. So it was that their kingdom rested on whether or not the sun would rise the next day over the horizon where it would usually then set. Whence, as the story is told, the sun changed directions and took the course which is present nowadays, rising in the east and setting in the west as a testimony in favor of Atreus. But before that quarrel between Atreus and Thyestes, the sun previously rose and set in the other direction until, as Euripides tells, strife changed the course of the sun's winged chariot, fitting the westward path of the sky towards the single strife changed the course of the sun's winged chariot, fitting the westward path of the sky towards the single horse of dawn. And Zeus diverted the career of the seven Pleiades into a new track and exchanged, and he goes on. I bring this up because our contention about whether the sun moves around the earth or the earth moves around the sun can be likened to this fable as a reverse conception of the motion of the heavenly bodies, and a reverse arrangement of the cosmos is the point of our contention. And we fancy ourselves to be contending for the throne of wisdom, which each of us can only secure by displacing the other's theory. Galileo, we do seem to be in a quarrel that can be likened to that myth. Simplicius of Cilicia. And we might also be likened to be quarreling over a golden ram, if we interpret that as the sun, perhaps with the addition of reaching the equinox in Aries. However, that aside, we might each pray out in bewailing grief and lamentation for the toil with which we are required to bear, as Electra cried out in the lines immediately previous to the line from Euripides I quoted. Oh, to reach that rock which hangs suspended midway between earth and heaven, that fragment from Olympus, which swings on chains of gold, so that I may utter lament to Tantalus, my forefather, who begot the ancestors of my house, interpreting each of our ancestors as the forefathers of our theories in this case. Galileo. That also makes for a suitable commencement for this part of the discourse, along with what I have already said. Simplicius of Cilicia. Yes, and we ought to return to the topic of our discussion before we let these fanciful poems sweep us away. Galileo. Then let us resume the discussion. And what follows will be a set of problems set forth towards the improbability of the Earth's mobility, or the movement of the Earth, the improbability of the Earth's motion, and towards the probability of the Earth's mobile nature. Now, having divided the cosmos into two parts, the Earth and the heavens, one of which must be responsible for the apparent diurnal movement of risings and settings, one of which necessarily must be movable and the other motionless. It is the same thing to make the earth move alone as it is to move all the rest of the cosmos, so far as any result in the phenomena which may depend on such movement. For the action of such a movement is only in relation between the celestial bodies and the earth, which relation alone is changed. This effect is commonly observed from aboard a ship at sea, from whose motion the coastline, which is necessarily motionless, is observed to move in the opposite direction as the sailboat really is moving. Now, if precisely the same effect follows whether the earth is made to move and the rest of the cosmos stays still, or the earth alone remains fixed while the whole cosmos shares in one motion, who is going to believe that nature, which by general agreement does not act by means of many things when it can do so by means of a few, has chosen to make an immense number of extremely large bodies move with inconceivable velocities to achieve what could have been done by a moderate movement of one single body around its center. And if we attribute the diurnal rotation to the highest heaven, as you say, then this has to be made of such strength and power as to carry with it the innumerable host of fixed stars, all of them vast bodies and much larger than the earth, as well as to carry along the planetary orbs, despite the fact that the two move naturally in opposite ways. Besides this, one must grant that the element of fire and a greater part of the air are likewise hurried along, and that only the smaller body of the earth remains defiant and resistant to such power. This seems to me most difficult. I do not understand why the earth, a suspended body balanced on its center and indifferent to motion or to rest, placed in and surrounded by an enclosing fluid, should not give in to such force and be carried around too. We encounter no such objections. If we give the motion to the earth, a small and trifling body in comparison with the universe, and hence unable to do it any violence. Now, for the sun to pass from one meridian to the other, for the sun to rise over this horizon and sink beneath that, causing now the day and now the night, and for the moon and the 5 planets and fixed stars to vary similarly, passing from one meridian to the other, rising above one horizon and sinking beneath the other. All these changes are in relation to the earth. All of them mean nothing except that the sun shows itself now over China, then to Persia, afterwards to Egypt, to Greece, to France, then Spain, and then America. And the same holds for the moon and the rest of the heavenly bodies, this effect taking place in exactly the same way. If, without disturbing any part of the universe, the terrestrial globe is made to revolve upon itself rather than the starry skies made to move circularly around the stationary earth. And here is a second difficulty for you, Simplicius. The probability that the motion of the earth and not the heavens, the probability of the motion of the earth and not the heavens being responsible for the apparent daily revolution of risings and settings is supported by the relative disruption of order that we should surely see existing among those heavenly bodies whose circulation is not doubtful, but most certain. This order is such that the greater orbits complete their revolutions in longer times, and the lesser in shorter. Thus, Saturn, describing a greater circle than the other planets, completes its cycle in 30 years. Then Jupiter revolves in a lesser cycle in 12 years, and Mars in 2 years, Venus in 3/4 of a year or so, and Mercury in less time than that, while the moon completes its cycle in a single month. And this very harmonious trend will not be a bit altered if the Earth is made to move around itself in 24 hours or a single day to account for risings and settings. But if the Earth is desired to remain motionless, it is necessary, after passing from the brief period of the moon to the other consecutive larger ones, and ultimately to that of Mars in 2 years, and the greater one of Jupiter in 12, and from this to the still larger one of Saturn, whose period is 30 years, it is necessary, I say, to pass on beyond to another incomparably larger sphere, and to make this one finish an entire revolution in 24 hours to account for the risings and settings of the luminaries, the daily risings and settings. Now, this is the minimum disorder that can be introduced. For if one wished to pass from Saturn's sphere to that of the fixed stars, and make the latter so much greater than Saturn's that it would proportionably be suited to a very slow motion of many thousands of years. A much greater leap would be required to pass beyond that to a still larger one, and then make that revolve in 24 hours. The period which we observe the luminaries to rise and set every day. But by giving mobility to the Earth, order becomes very well observed among the periods. From the very slow sphere of Saturn, one passes then on to the entirely motionless fixed stars, and manages to escape the difficulty necessitated by supposing the stellar sphere to be movable. Then, and this is the third difficulty you must face, there is a difficulty of the immense disparity between motions of the fixed stars themselves, some of which would be moving in very rapid cycles. Some of which of the fixed stars would be moving very rapidly in vast cycles, and others slowly in smaller cycles, accordingly as they are located further from or closer to the poles. This is indeed a nuisance, for just as we see that all those bodies whose motion is undoubted move in large circles, so it would seem to have been good judgment to arrange bodies in such a way that they must move circularly at immense distances from the center, and then make others near the poles move in small circles. Thus, the size of the circles and consequently the velocities of motion of these stars would be very diverse from the orbits and motions of some others. Simplicius of Cilicia. As to your first point about the greater force needed to move the immense sphere of fixed stars holding the 36 constellations, along with the luminaries at a much greater velocity than would be needed to turn the Earth, a body of lesser mass, around its own axis. I only need remind you that the motion in question isn't constrained, forced, or external to the body in question, but natural to effortless, in the same way that it is effortless for fire to move upwards, and for whom a greater mass of fire means a greater upward velocity, due to the peculiar substance of the circular revolving orbs. This is evident in the uniform and regular motion of the heavenly bodies, whose velocities and pace are always even, without either acceleration or retardation, without either slowing down or speeding up. Such would not be the case if the motion was forced upon them externally, which would rather result in a motion that begins more rapidly than it continues with and gradually becomes slower, in proportion to the exhausted effort of the mover. But the outermost sphere that carries around the fixed stars and luminaries, rising in the east and sinking in the west in a daily 24-hour cycle, never moves irregularly, always keeping to a uniform and steady velocity without acceleration or declination of pace. That tells us that the exertion of force is not constrained, but natural to that substance. Also, as the heavenly bodies and above all the fixed stars are primary and more complete than the earth and elemental bodies, they are more apt and better suited to be responsible for the apparent daily revolving of the luminaries and fixed stars. Then, as regards to the same problem, if the earth is to move, whether occupying the same place and revolving around its own center, or along a circumference and around a center different from its own, being removed from the center, it must be moved with such motion by restraint and external force as if pushed along, for this is not the earth's natural motion. If circular motion was natural to it, all of its parts would move circularly also, but every one of its parts is moved along a straight line towards the center. Aristotle gives a cogent argument in accord with the previous argument, which is also his. He asks, why then is not the whole body of the cosmos of the same character as the revolving heavens? Because there must be something at rest at the center of the revolving body. We take this for granted, as the apparent motion in question demands a changing relation between the positions of the luminaries and the earth. And of the revolving sphere of fixed stars, no part can be at rest, either elsewhere or at the center. What I mean is that for there to even be an apparent change of circulation, if a sphere of a continuous mass were turned around itself, the center would move with the circumference and you would not see the difference that we are trying to account for of risings and settings. If the center globe was turned with the same motion as the outermost. This is evident in the consideration that the turning of a solid sphere of a single material has only a magnitudeless point unmoved at its center, if that. And we are inquiring after a center that is not a magnitudeless point, but one with magnitude, the sphere of the whole earth, which would be carried along by and with the same circulation of the outermost sphere, if not separate from them in substance and having a distinct natural motion. Again, there must be at least one other motion besides the circulation of the outermost sphere, since a single motion of the whole heaven would necessitate an identical relation of the elements of bodies to one another, indifferently. Then also, if the sun were the body at rest at the center of the cosmos, we should expect to find that the parts of the sun move towards the center on their own accord. But if the sun is taken to be located at the center, and the rays of light, which are the only noticeable parts of the sun, expand outward away from itself, then adium est ratio totius et partium. Adium est ratio totius et partium. The sun won't as a whole have a natural place of rest where the parts, in this case, the rays of light, don't move towards on their own accord. That is to say that the sun shouldn't be thought of as placed at the center of the cosmos, because the parts of the sun do not move there. This then is to say that the earth should be thought of as located at the center. If something must be at rest, or at least have a separate motion different from that of the diurnal motion of risings and settings, to account for the relative change of the position of luminaries among the fixed stars and of risings and settings. And the parts of the earth move naturally towards the center, at which point they rest, at least as parts. And a single simple body can only have one natural motion. Then the earth, rather than anything else, must be at the center. As to the second problem you posed, which you call a disharmonious arrangement in the progression from near to far, of shorter to longer periods of time of each cycle. In other words, why the fixed sphere, in other words, why the sphere of fixed stars, which is at an incomparable distance from us than the planets, with its diurnal motion, revolves every 24 hours, while the planetary spheres revolve in an orderly progression. The nearer they are, the faster they complete their cycle. And the further they are, the slower they complete their cycle. I have the following resolution to state. The planetary and solar and lunar cycles obey their harmonious progression, as you say, the nearer luminaries completing their cycles faster, and the further planets completing their cycles more slowly, each contiguous with the next, moving from west to east through the zodiac. The cyclical motion of the fixed stars, however, although continuous with the outermost planetary sphere, revolves from east to west in the direction reverse that to the planetary, solar, and lunar movements through the zodiacal signs. So, your suggestion that passing from the furthest planetary sphere to the sphere of the fixed stars breaches the harmonious progression that was found in passing from the innermost towards the outermost planetary cycles ignores the difference in species of motion, or at least direction of motion, between the two orders. As the risings and settings revolve in a different direction than the progression of the planets through the zodiac. Each of the planets and the sun and moon move with their own separate motion, unaffected by and not affecting the other planetary motions they are contiguous with, again, from west to east. They are all, however, at the same time carried around in the opposite direction from east to west, along with and by the sphere of fixed stars that rotates most rapidly with a 24-hour cycle, accounting for the rising and setting every day of all the luminaries. Thus, the planetary and solar and lunar spheres share in east to west motion that is imparted to them from the outermost sphere of constellations, while the latter is no way affected by each separate and much slower planetary motion through the zodiacal signs from west to east. The diurnal 24-hour cycle of risings and settings is then common to all the inner spheres besides the earth, and you need not doubt the concordant role played by the outermost sphere, or consider such an arrangement to be disharmonious. For the harmonious cycles of the inner spheres span from 28 days to 28 or 30 years, and they require a faster cycle to carry them around the whole circle once a day. For if you object to this as mere fancying on my part, then I ask you, with what measure, if you take away the diurnal motion of risings and settings, could you use as the unit of measure for your harmonious progression? What I mean is this. The shortest cycle is that of the moon, spanning 28 days. And if you take away the rising and setting that causes the division between and repetition of days and nights, for that is not the sun's own motion, you will have no unit of measure to compose the month. And without the month fixed to a certain number of days, if days are to be rendered meaningless, without the risings and settings that create day and night, the month will be indeterminate without discrete units of measure. Then in turn, the annual or yearly cycle of the sun would suffer the same fate without the discrete measure of days and a determinate month. You may respond that the sun's apparent rising and setting over the horizons can equally be accounted for by the rotation of the earth about its center. However, that is not the question at hand, and it was already shown that the celestial bodies move with unrestrained motion natural to them, that is orderly and invariant, is natural to them, as upward motion is natural to fire, and as falling motion downward is to earth. You pose a third problem, that if the outermost sphere of fixed stars is in motion, then there would result a great disparity in diversity of greater and lesser velocities and distances, with stars at vast distances from the center moving at very rapid velocities, and stars verging towards the poles moving at much slower velocities. You say that such an arrangement would be a nuisance and bad judgment, presumably with your eye set towards keeping harmony free from inequality. That is, however, a natural property of spheres and of circular motion in general. For when multiple circles are inscribed concentrically around the same center and revolved around their center so as to complete each of their cycles in equal time, the circles with shorter radii while completing their cycles in equal time with the circles with longer radii cover a lesser distance. Now, there are two ways of defining the faster. The faster traverses an equal distance in a shorter amount of time, of course, but the faster also traverses in an equal amount of time a longer distance. So, given the second definition of greater speed, circles with a greater radii will, by traversing a longer distance in equal times, be faster. The stars located near the ecliptic must have a greater velocity in proportion to the greater distance they cover, while inscribing their circuit in an equal time with the stars verging on the poles, which by covering a lesser distance in an equal time must revolve at slower velocities. Yes. That is the natural property of a sphere turning upon itself, that the equatorial latitude carves out a greater circumference, and the polar latitude, where the Great Bear and the Lesser Bear are, carve out a lesser circle, so that while the whole sphere turns and rotates within the same distance of time, the greater distance of space of the circumference carved out by those near the equator from those lesser circumferences near the polar regions will obviously mean that the equatorial circumferences and the stars there will have to be moving faster than the stars near the poles, which we observe moving very slowly around a lesser circle, which is a regular property of moving spheres, a very elementary problem. That is not a matter of disharmony. Again, these arguments are taken straight from Galileo's. These challenges are verbatim Galileo's challenges to Simplicio in his dialogue concerning the two chief world systems. The perfection of the spherical and of the circular shape indeed is a wonder to contemplate. However, that is not so much as the beginning of the awe that can be drawn from such speculation. That while turning around itself, a sphere, the parts of a sphere that are on the circumference by covering a greater distance in the same amount of time, move faster. And so the parts of a sphere near the equatorial line move faster while covering a greater distance in the same amount of time as the polar stars near the North Pole that carve out a lesser circle and cover the lesser circle in the same amount of time. You merely point out that there is an apparent inequality and think this to be a great disparity. You perhaps expect to find arithmetical equality, but much more beautiful is geometric or proportional equality, which is displayed in the characteristic of revolving spheres. For in keeping to equal times in completing their circular motions, the sections of the sphere rotating around the axis, not the center of the sphere, about which they have all equal radii. They maintain a speed proportionate to their distance from the center of their circle, so that the whole and each of the parts revolve around the axis in an equal amount of time. Since there are an infinite number of divisions that can be made along the axis of the Earth, and further latitudinal lines can be drawn between any 2 points on that line. And given what was said, an equal amount of time for all circles along a sphere to complete their rotation around the axis as their common center is preserved amidst the infinite inequality of distances from the axis, as by adapting each of their speeds proportionally to their distances, thus preserving the equal time of rotation. This is important. Since there are an infinite number of divisions that can be made along the axis of the Earth, the pole that connects the North Pole to the South Pole of the Earth, and the divisions are cut accordingly. That axis is what any globe is turned around. And given what was said, an equal amount of time for all circles along a sphere to complete their rotation around the axis, you have an equatorial star carving out a greater circle around the axis pole of the sphere in the same amount of time, completing the movement around a greater circumference as one around the pole, completing in the same amount of time the lesser circle at a lesser speed. This is about proportion. An equal amount of time for all circles along a sphere to complete their rotation around the axis as their common center. So an equal amount of time for the different parts of the sphere to complete their rotation around their common axis is preserved. The equal amount of time is preserved amidst the infinite inequality of distances from the axis, as nearing to the poles results in a lesser distance around the axis, and nearing to the equatorial line results in a greater distance, while they maintain the completion of their circuit in a equal amount of time. By adapting each of their speeds proportionately to their distances, thus preserving the equal time of rotation. Again, by adapting their speeds proportionately to their distances, one being a greater circumference, one being a lesser circumference, adapting the speeds around those circumferences to their distances of the circumference proportionally, thus preserving the equal time of rotation amidst the infinite inequality of distances from the axis. There might be one between the polar stars and the equatorial, and then there might be those between those. And there's an infinite amount of differences in distances from the axis line, which different stars at different latitudes carve out, but turned around as they are all part of the fixed stars, an equal amount of time of 24 hours to complete their rotation. So that their speeds are adapted proportionately to their distances, preserving the equal amount of time of their rotation, as obviously the sphere completes the rotation as a whole with an equal amount of time for the parts of the sphere. But the parts of the sphere carve out different circumferences, some of them more, some of them less, and their speeds are adapted proportionately to their distances, so that the stars nearing the polar region that carve out a lesser circumference move slower, very slowly around a slower circle, very slowly around a lesser circumference, while those around the equator carve out a greater circumference and so move with a greater speed, since those circuits are completed in the same amount of time. As we said, speed was defined in one sense as the faster covering a greater distance in equal times, that the less fast completes a lesser distance. You might fall deeper into wonder when we reconsider the previous problem under this light. For what you thought was out of place and discordant, the rapid speed of the outermost sphere of constellations, the completion of its rotation in 24 hours, will turn out to be a wonder and spectacle of harmony and concord. Again, you said that we should not expect the outermost sphere to move with such an inconceivable speed. When we find that the planetary orbits and those of the sun and moon are slower at greater distances and swifter at nearer distances. You figure that if the proportion is held in accordance with the inner spheres, the outer sphere should revolve at a very slow speed, as all the inner spheres are slower in proportion to their distance from the center. Let me read this again. You might fall deeper into wonder when we reconsider the previous problem that preceded that under this light. For what you thought was out of place and discordant, the rapid speed of the outermost sphere of constellations completing its rotation in 24 hours, will turn out to be a wonder and spectacle of harmony and concord. You said that we should not expect the outermost sphere to move with such an inconceivably rapid speed. When we find that the planetary orbits and those of the sun and moon are slower at greater distances, as Saturn revolves in 30 years, and swifter at nearer distances, as the moon revolves in less than 30 days. You figured that if the proportion is held in accordance with the inner spheres, the outermost sphere should revolve at a very slow rate of speed, as all the inner spheres are slower in proportion to their distance from the center. I already argued that the outermost sphere revolves in the opposite direction of the planetary spheres and those of the sun and moon. You know, of course, that the planets and sun and moon share in the daily circuit of risings and settings by participation, and that their own separate motions are not east to west, but west to east through the zodiac at the slower rate of a month, a year, 2 years, 12 years, 28 or 30 years. You also know that the revolving outermost sphere that against our horizon provides for the risings and settings of all the heavenly bodies, carries them around uniformly so that they complete the daily cycle in equal times to their position according to long lines of latitude. That is only to set the problem conformable to the terms we were recently using regarding the proportionality of unequal distances and speeds to produce an equality of times of completed circuits. Consider this then. Are not the relative speeds of the planets and sun and moon opposite to how we have been considering them amongst their own separate motions west to east? We said that as we passed from near to more distant spheres, we found that the speed and time it took them to complete their separate cycles decreased from the moon with the swiftest cycle to Saturn with the slowest cyclical completion. That, remember, is true regarding their west to east motion through the zodiac or ecliptic. As regards to their east to west motion in common with and by way of the outermost sphere, from which they are observed to rise in the east and set in the west, we find that the near planets move slower and the further planets move faster. This is in accord with the properties of a rotating sphere and of those of the rotation of concentric cycles. This is in accordance with the properties of a rotating sphere and of those of the rotation of concentric circles, where the greater the distance from the center, the greater the speed given that the time for them all to revolve around the center is equal. So we find that the speed of Saturn, which has the slowest transit through the zodiac, because it is further, is fastest among the planets by way of covering a greater circumferential distance in equal times with all the lower planets. And we find that the speed of the moon is slowest amongst the luminaries in the daily circuit from east to west of risings and settings, for the reason that the moon covers the least circumferential distance in the same amount of time in which the other planets cover a greater circumferential distance. Is this not a spectacle of wonder that in their own separate motions through the zodiac, the moon has the fastest cycle of 28 or 30 days, and Saturn has the slowest of 28 or 30 years? But in their common motion derived from the outermost sphere, from which they appear to rise over the eastern horizon and set over the western horizon. Their relative and proportionate, I should add, speeds are the inverse. Their relative and proportionate speeds are the inverse, with the moon traveling the slowest and Saturn the fastest in proportion to their distances from the center. Meanwhile, revolving all the way around in the same and equal amount of time, 24 hours. A reason for this may be provided that is given by Aristotle in his response to the question why the outermost sphere, which carries around a great multitude of stars, has but one motion, that is east to west, while the planetary spheres carry around a single luminary and have three motions. The daily east to west motion common to them all, that is shared, their separate transits through the zodiac west to east, and their periodic retrograde motions east to west. While the sun and moon have two motions, those of the planets accepting the reverse motion of periodic retrograde. He says that nature works like a balance and establishes equality. We might add sometimes equality by arithmetical proportion, sometimes by geometrical proportion, and sometimes by harmonic proportion, giving to a single motion many bodies, that of the outermost sphere of fixed stars, and to a single body many motions, that of the planets, which have three different motions, one rising and setting, one through the zodiac, and retrograde backwards through the zodiac. We might adapt the answer to our present ends and say the same applies to the inversion of order of proportional speeds amongst the planets and sun and moon. Then nature, like a balance, makes matters equal, adding more Tyrian dye to one end of the scale and more silver to the other end, and establishes a certain order, so that the swiftest east to west is Saturn, and the slowest in that direction of risings and settings is the moon. And while at the same time, the moon is swiftest west to east in her transit through the zodiac, and the slowest in that direction through the zodiacal constellations is Saturn. Again, we might adapt that answer to our present ends and say the same applies to the inversion of order of proportional speeds amongst the planets and sun and moon. Then nature, like a balance, makes matters equal, adding more Tyrian dye to one end of the scale and more silver to the other. Note that nature isn't making a balance between Tyrian dye and Tyrian dye, or between silver and silver, but between different things that have to be measured out in proportion that are not equal in weight, but that a certain amount of Tyrian dye, a certain amount of weight of Tyrian dye equals a certain amount of weight of silver. And the weights are not equal, but the value is. So nature, like a balance, makes matters equal proportionally, adding more Tyrian dye to one end of the scale or more silver to the other end, but not balancing like with like in homogeneous arithmetical equality. Adding a certain amount of Tyrian dye, say a tenth of the weight of the silver, and according an equality of the value of Tyrian dye as 10 times that of the value of silver, for example. And the value of silver, while weighing 10 times more to an equal value of Tyrian dye, which weighs 10 times less. For example, I don't know the price. Tyrian dye is expensive, and silver is the best and proper mode of currency. And every European country should use silver as currency. Then nature, like a balance, makes matters equal, adding more Tyrian dye to one end of the scale or more silver to the other end, and establishes a certain order proportionally, so that the swiftest east to west is Saturn, and the slowest in that direction is the moon of daily risings and settings. Since Saturn turning around, risings and settings, everything happening once a day, the single motion of risings and settings, the further planet carving out a greater circumference in an equal amount of time with a lesser circumference carved out by the moon in the same amount of time. Then Saturn covering a greater distance in the same amount of time as the moon, which covers a lesser distance in the same amount of time, moves faster. So that the swiftest east to west of rising and setting is Saturn, and the slowest in that direction is the moon. While the moon is the swiftest west to east through the zodiac, completing her cycle in 28 days or 30 days, as some say. And the slowest in that direction is Saturn, completing his cycle in 28 or 30 years. That is to say that what Galileo considers as a disharmonious sort of arrangement is really, for one, the very obvious properties of the rotation of a sphere and the different speeds of different parts of the sphere to turn around the axis in the same amount of time. And something sort of wondrous about the inversion between the two orders of progressions, or the two orders of proportional progressions from slower to faster depending on distance. And I should highlight the differences in kinds of equality, where the amount of Tyrian dye is measured in value by weight. And the value of silver is measured in weight. But those weights, while not being equal, are made proportional and the value is made equal because their weights are established according to value. And then say 10 times more silver is equal in value to 10 times less Tyrian dye, while the weights are unequal. Or yet the weights are equalized and the value is 10 times more. That then is my response to your problems posed against the theory of the Earth's immobility. Now I will in turn pose problems against your claim that the Earth is in motion. Notice this, you say that the theory of a moving Earth and motionless heavenly spheres is capable of accounting for the same phenomena as does the theory of the motion of the heavens and the immobility of the Earth. According to you, both theories are able to explain the same apparent motion. From there, you rely on probability and improbability, never proving or even arguing for the impossibility of the Earth's motionlessness, and never proving the necessity of the Earth's motion. We, however, we don't admit that any movement of the Earth can account for the same celestial phenomena as the immobility of the Earth, along with the movement of the heavenly spheres. So instead of relying on arguments from probability and improbability, like some menial gambler, I will argue against even the possibility of the mobility of the Earth in accounting for the relevant celestial phenomena and for the necessity of the immobility of the Earth and the necessity of the movement of the heavenly spheres. If the relevant celestial phenomena can be accounted for at all, I won't rely on probability and improbability at all. And I will reduce the problem to terms of impossible or necessary. I have presumably escaped the difficulties you set me. I have presumably escaped the difficulties you set to me regarding the probability or improbability of the Earth's movement. You haven't, however, set forth a single argument that the motion of the heavenly spheres is impossible, or that the immobility of the Earth is impossible, or that the motion of the Earth is necessary, or that the immobility and motionlessness of the heavenly spheres is necessary. I, however, along with the philosopher, as some call him, or as we do, the daimonical Aristotle, wish to argue that I, however, along with the philosopher, as some call him, or as we do, the daimonical Aristotle, wish to argue that the mobility of the Earth is impossible and that the immobility of the heavenly spheres is impossible, and that the immobility of the Earth is necessary, and that the mobility of the heavens is necessary. I need but one argument to prove this, yet subsequent arguments will fall into place behind the marshalling first, in proportion to the divergence of views you possibly hold regarding the type of movement you ascribe to the Earth. I will stop there, and I want to repeat that the challenges that I present Galileo as setting for Simplicius are the challenges that he set for his character Simplicio in his dialogue concerning the two chief world systems. I simply took the best of his challenges about the probability that the earth more probably moves around the sun, and that the sun more probably doesn't move around the earth. I took the best of those arguments that he made, and I set those up and responded with what was already there in the Aristotelian tradition and in the writings of Aristotle, the arguments against those things, which these excessive footnotes, the excessive footnotes reveal. There are Galileo's challenges, which can be found in his dialogue, book 2, just like this is book 2, and Aristotle's response in On the Heavens in various places, which had to be found, of course, in different places and adapted to the specific problems set forth by Galileo. But again, Aristotle addressed specifically the heliocentric model of the cosmos because there were people in Greece, there were Greeks arguing for that also. And he addressed that, but he addressed that briefly, and he considered his argument complete. He considered to have just disproved the possibility of that. That's impossible. While Galileo worked his way into a weighing out of probability by saying that both models of the cosmos can account for the same phenomena, while Aristotle did not admit that, but said that the earth could never be in motion, because then there'd be a change, because then we would not find the same fixed stars at the same latitudes, and we would find the North Star changing, but the North Star remains fixed and the fixed stars remain at the same latitudes. And there is no north or south motion that the fixed stars have, which will be the topic of the next section. Aristotle's arguments against the heliocentric model of the cosmos, which are not about probability of this being more probable than that, or that being less probable than this, but about the impossibility of that heliocentric theory to even account for the phenomena in question. While Galileo says that both can account for the phenomena. It doesn't disprove the geocentric model, but Aristotle already had disproved the heliocentric model. So I will stop there and continue with the next section, as this can be considered Galileo's challenges. This is the most important, these are the more important and weightier arguments that Galileo has, that are more just in the sense of challenges for the Aristotelian framework. And those have been addressed. While the next section will be Aristotle's simple argument that disproves even the possibility of the earth accounting for the risings and settings, and of the sun varying north and south, which will be clear.